All right, so for question number 1, we're asked to solve the equation. So we have our rational equation. Remember, to solve a rational equation, you want to figure out what the least common denominator is. In order to do that, we're going to need to make sure that every denominator is in factored form. This one right here is not factored. So we're going to take a minute and we want to factor that. You can factor it just using your asterisks. So if I factor that denominator, I would have 1 in the top left and top right, 5 in the bottom middle, and -6 in the top middle. Then we're on a mission to find two numbers that multiply to give us -6 and add to give us +5. 6 and -1. So then we're looking at both of our fractions here to see if either one of them reduces. In this case, neither one reduces. So we're going to go back to the original. We're going to mark out this quadratic and we're going to write what we just factored it into, m plus 6 and m minus 1. So now my least common denominator is going to be anything that's a part of any of the denominators. In this case, it's just going to be m plus 6 and m minus 1. No. So that's going to be the least common denominator. Since there's an equal sign, we're going to multiply every single term by the least common denominator. So I'm going to multiply every single fraction by m plus 6, m minus 1. And then if we've done this correctly, something should cancel in every single fraction. So we have 3 fractions, which means we should be able to cancel at least 3 things. So looking at the first fraction, the denominator's m minus 6, we're multiplying the top by m minus 6, so those are both going to cancel each other out. That would leave us with 4 and then m minus 1 in parentheses. If you wanted to go ahead and just distribute, write 4m minus 4, that's okay. Then we have a plus sign. For the second fraction, we're looking, I have an m minus 1 in the denominator and m minus 1 in the numerator. I'm going to cancel those out. That leaves me with 1 and then m plus 6 in parentheses.
What if I just already put it together?
That's fine. So you could go ahead and distribute that 1. In this case, it wouldn't change anything. And then your last fraction, the m minus 1's cancel, the m plus 6's cancel, and you're just left with 3m plus 6. Now you have a linear equation that you need to solve for m. So first thing you want to do is get rid of your parentheses by distributing. So we're going to distribute the 4 into this set of parentheses, 1 into this set. So 4m minus 4 plus 1m plus 6 equals 3m plus 6. And I realize some of you might already have that because you just distributed when you wrote that first line. Once you get here, my suggestion would be that you combine like terms. So here I have like terms. I would add those two together. They're both on the left side of the equal sign, so I just add them the way that they are. 4m plus 1m is 5m. Then again, the -4 and the +6, both on the left side of my equal sign, so I'm going to add them together. When I add -4 and +6 together, I get +2. So now I have 5m plus 2 equals 3m plus 6. we're trying to get m by itself. We need to move 1 to the other side. Which one do you want to move? The 3m, I would move the 3m. It's positive, so I'm going to move it by subtracting 3m from both sides. So that gives us 2m plus 2 equals 6. We now want to subtract 2 to move it to the other side. So we're subtracting 2 from both sides. That gives us 2m equals 4. Divide both sides by 2 to get your final answer. M equals 2. Please make sure, again, this is going to be multiple choice on your actual test, but if it's not multiple choice, please circle box your answer so I know what your answer is. Questions on this one? Am I going too fast? Okay. Question number 2, we're going to determine whether or not this function is 1-to-1. So here we were given what type of function? What is this? Quadratic, linear, cubic? It's quadratic. We know that a quadratic always looks like a parabola when we graph it, right? Parabolas look like this. You could flip it upside down if the first number was negative. But anyway, you know that this is a parabola. I want to know if this is 1-to-1, which means I need to take the horizontal line test. If I draw a horizontal line on actually either one of these graphs, does it pass that test? Does it touch my graph more than once? Yeah, it's crossing twice, so this is not 1-to-1. So it has to pass the horizontal and the vertical line test, but it tells you that it's a function, so it has to pass the vertical line test. To be 1-to-1, then it would also have to pass the horizontal line test. So since it's quadratic, we know that it's going to look like a parabola. So any parabola you can pick, it doesn't matter. You know it's going to be a parabola. It doesn't matter where we move it, shift it, stretch it, shrink it. It's still not going to pass.
So if it got an exponent, it's always a quadratic.
If it has an exponent of 2.
So is this what we're gonna have to write?
You just tell me it's not 1-to-1. You don't have to write out an explanation. I just wrote out the explanation so that when you look over this before you take your test tomorrow, you know exactly why we put one, that it was.
So how will we know if it has the horizontal line?
So if it's a quadratic x squared, it's going to be a parabola. No parabola will ever pass the horizontal line test.
That if it's a quadratic, it always pass.
It will not pass. So since it's a quadratic, it didn't pass that horizontal line test, so it can't be 1-to-1. It told us it was a function, so it passed the vertical line test, but it won't pass that horizontal. Question number 3, what's that?
I was just gonna say, would you want us to do the arrow to you with set face?
You don't have to. Like, that's just how I visualize it in my mind. I'm looking for the word no. Or not 1-to-1. Something of those sorts. Question number 3, solve the compound inequality, write the solution set using interval notation and graph it. So think back to Algebra 1. I think we did some of these at like the beginning of the term, which has been forever ago. Since this is a compound inequality, we have 2 problems. We have this problem right here, and we have this problem right here. So we have two problems. The center portion is always going to get used twice. So we're going to break it apart into two problems. -7 is less than, negative 3x plus 5. That's the first problem. That's my red box. And we're also going to solve the green box. Negative 3x plus 5 is less than or equal to 5. So we broke this up into two problems. Again, that middle portion gets used twice. Then we're just going to solve both of these. Remember the rules for inequalities. Anytime you multiply or divide by a negative number, you have to flip the sign. Doesn't matter when you add or subtract. So if I'm going to solve for x, I'm going to work on the problem on the left. First thing I would do is subtract 5. When I subtract 5, -7 minus 5 is -12. So -12 is less than negative 3x. And go. Ooh. To get x by itself, I'm going to have to divide by -3. Anytime you divide by a negative, you must flip your inequality. So my inequality is currently less than, now it's going to be greater. On the right side, the -3's cancel, leaving you with just x. On the left side, -12 divided by -3 is +4. And then remember with inequalities, you always want to write x on the left side. So if I flip this whole thing over, x would be less than 4. Then we're going to do a similar process on the other question. We're going to, again, solve for x, subtract 5 for both sides. So now we have -3x is less than or equal to 0. We want to divide by -3. So x, when I divide by a negative, I have to flip my sign. So now my symbol is greater than or equal to instead of less than or equal to. 0 divided by -3 is still 0. So then remember, for compound inequalities, you want the region that's overlapped by these two statements. So I need all the numbers that are less than 4 and greater than or equal to 0. So that's going to be any number between 0 and 4. So 1 is less than 4 and greater than 0. And then we have to think about our symbols that we're going to use. So remember, if it's equal to, we use the bracket. If it's less than or greater than, we're just going to use a parenthesis. So x is less than 4 is just going to be a parenthesis. Greater than or equal to 0 is going to be a bracket. Now it's for 2. All the way back at the beginning. It's multiple choice. There's also, when you write your solution set using interval notation, again on your test, you're going to have the graph, which is enough for you to get your answer, but they'll also have like the corresponding answer that goes with it. in this case, this would be my other answer that you could also look for. But like I said, once you get the graph, you should be able to pick the correct answer just off that. Question number 4, a ball is thrown downward from a window in a tall building. Its position at time t in seconds is s equals 16t squared plus 32t, where s is in feet. How long to the nearest tenth will it take the ball to fall to 92 feet? So we were given an equation here. Oops. We were told s is in feet and t is time in seconds. And then we were asked to find how long is it going to take the ball to fall 92 feet. Where should I plug that 92 in? Should I plug it in for s or should I plug it into t? S. So I'm going to the equation that they gave us. I'm going to plug in 92. And then I'm going to leave everything else the same because we're trying to solve for the time t. So when I look at this, it is a quadratic. I would want to get 0 on one side, so subtract 92. So I could try to factor this using my asterisks, but when I would fill out my asterisks, when I took a times c, I'd have to take 16 times 92, which is going to give you a gigantic number. So first thing I would do is try to reduce this. Can you think of a number that you can divide all 4 terms by? Well, they're all even, so you can at least do 2. I would check 4. Just to make things easier. So I would try to divide everything by 4. Again, that just makes smaller numbers for you to look at. So 0 divided by 4 is 0. 16t squared divided by 4 is 4t squared. So that gave me 4t squared plus 8t minus 23. Unfortunately, that still does not factor. So you're going to have to use the quadratic formula. It is given to you on your reference sheet. So remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're just going to plug these 3 numbers into a, b, and c to find our solutions. So I'm going to work over here at the top. So x equals negative b. I want the opposite of positive 8, which is negative 8, plus or minus. Underneath our square root, we need b squared. So we need 8 squared in parentheses minus 4 times a, which is 4, times c, which is negative 23. all divided by 2 times a, so 2 times 4. And then as always, we're going to type just this portion right here into our calculator. Somebody tell me what you get when you type that in your calculator. 432. Check to see, is 432 a perfect square? Can you square root it and get a perfect answer? Yep, nope, the x squared, because you're square rooting. That's not. What'd you get for your decimal? Yep, 20.78. So since this is a word problem, we can't leave our answer like this. We're trying to figure out how many seconds to the nearest 10th does it take the ball to fall 92 feet. So we're going to take 20 point, let's maybe. So we're going to have to actually figure out what two numbers this equals. I can only assume that one of them is going to be positive and one of them is going to be negative to get our answer. So if you're going to separate this into two parts, again, you're going to use the plus sign for one, so -8 plus 20.78 divided by 8, and then -8 minus 20.78 divided by 8. If you're going to type all of that into your calculator at once, you've got to put parentheses around the numerator to get the correct answer. No, because it's a word problem. You're trying to figure out how many seconds it takes. So you have to just convert it to a decimal regardless of what you get underneath it. And on your test, it's not going to be a perfect square, but you just want to figure out the decimal equivalent and move on. So when I typed this first one in my calculator, I got 1.5975. Our instructions up here say round to the nearest 10th. That's one place after the decimal. So I would just write 1.6. And then we're talking about time. So we're going to label it as seconds. And then just to double check that the ball's not at 92 feet more than once, we're going to do the second one. Take -2 minus 20.78. Either put that in parentheses or hit equals and then divide it by 8. You get -3.6 seconds. Again, we never measure time as a negative. So that one's extraneous. We didn't do anything wrong in the problem. It just doesn't make sense that you threw a ball and you said it was at 96 feet and -3.6 seconds. So only answer we have here is the 1.6 seconds for the ball to reach that. Questions on this one? So kind of a classic quadratic formula word problem. Mm-hmm. The numbers are smaller on your test though. Like you won't have to reduce them on your test. You just leave them as they are, jump to your quadratic formula, which is given to you on your reference sheet. And then whenever you get to this point, you're just going to find the square root of whatever you have, plug it right there, break it in piece, into two pieces to find your decimals. One of them will be positive, one of them will be negative. Remember, time's always positive.
How do you plug it into your calculator?
Plug this into your calculator,
Well, the other part.
this part. So I would just type this top piece in parentheses and then divide it by 8. Or you could type -8 plus 20.78 equals, and then divide that answer by 8. So equals and then divide by 8. So there's more than one way you can do it to still get the same answer. Question number 5, we're going to graph this function. This is a piecewise function, which means according to the constraints, we have to do two different things. So, excuse me, our constraints are over here. So any number that's less than -1, we're going to have to make an XY chart for. And then for the bottom one, we're going to have to make an XY chart for any number that's greater than or equal to -1. So I'm going to start with the top one. So that's going to be, remember that this is pointing to the left. So my arrow is going to go to the left. So I'm going to make my XY table. And this is going to be the left side of my graph. And then I want any number that's less than -1. I'm going to start with -1, but keep in mind when I start with -1, since there's not an equal to underneath this, that it's going to be an open circle. So I'm going to write myself a note that's going to be open. And then again, I can pick any number to the left of -1, so I could do -2, -3. If I was being crazy, I could do like -5, -10, any number that's less than -1. So any number that's smaller than -1 will work. Keep in mind that -1, since there's not an equal to underneath this here, it's going to be an open circle. So then with these 5 numbers I just wrote down, you don't really have to have 5. Those are just what I picked. We're going to plug it into x plus 4. So we're going to take all these x values, and we're just going to add 4 to them. So -1 plus 4 gives me 3. -2 plus 4 gives me 2. -3 plus 4 gives me 1. -5 plus 4 gives me -1. And -10 plus 4 gives me -6.
How many x's do you need?
I would say a minimum of 3. So minimum, I would do 3 just to make sure you're on the right track. I picked these 2 last ones because it's going to give me stuff over here further on the left side of my graph. So I'm going to put an open circle at -1, 3. -1, 3 means I start at the origin, I go left 1, up 3, I'm putting an open circle right there. Do not fill that circle in because this cannot equal that -1. The next one will actually do our articles. Then we're going to go to -2, 2. -3, 1. 5, -1. And -10, -6. And which way am I drawing my arrow? To the left. So this one gets the arrow on it. That is half of my graph. So for this part of the graph, we need numbers that are greater than or equal to -1. We're going to keep the -1, but then when we fill out the rest of the numbers, they have to be greater than -1. So for -1, we're going to write myself a note that's closed, circle, and this is going to be the right side. So if it's going to be the right side of my graph, I'm going to have to pick numbers that are on the right side of -1. So I could pick 0, I could pick +1, I could pick +5 and +10. Again, the 5 and the 10 just give me more numbers to get a more accurate graph. But as I said earlier, this test question is going to be multiple choice. That doesn't mean rush through it. Don't take your time. Make sure you're looking for open and closed circles. I would go ahead and do all this work and then just check to see which one has a left side that matches this exactly. Which one has a right side that matches this exactly. Because if you miss a multiple choice question, you miss all the points. Which sucks. So then I'm going to take these 5 numbers that I picked them all because they're all greater than or equal to -1, which is that second constraint for our piecewise graph. So we're down here now. And then
Here.
so we're going to just plug into -x, which just means I'm going to change the signs of all of them. So -x just means take the original sign and change it. So -x, if I want -1 in there, it's going to be +1. Well, 0 doesn't really change signs, so it's going to stay 0. +1 is going to change signs to -1. 5 is going to change signs to -5. And 10 is going to change signs to -10. Then I'm going to graph these 5 points. Keep in mind that -1, 1 is a closed circle this time. 0, 0, 1, -1, 5, -5, 10, -10, all these points here. When I connect them, which way will my arrow go? Down and to the right. Perfect. So this right here would be my final graph. Questions on this one? Question number 6, we just did this last week. An initial investment of $480 is appreciated for 2 years in an account that earns 17% interest. Keyword compounded quarterly. Whoops, I just marked it. Quarterly keyword there. Find the amount of money in the account at the end of the period. So we have some numbers that are important. The word appreciated is important. What do you think that means? If I'm So appreciated, I'm gaining money. Remember, depreciated, you're losing money. So we have that formula that we gave to you last week, that A equals the principal, and then in parentheses 1 plus R divided by N to the NT power. This formula is given to you on the top right of your reference sheet. On the back side, depending on which side you look at. So we need to figure out where these numbers go. We know we're trying to find the amount, so A is not going to change. P was the initial principal. What was our principal or our money that we invested? $480. In our parentheses, it's always 1 plus because we're gaining interest. For the fraction inside our parentheses, what does R represent? The rate. If you forget, it tells you on your reference sheet. So there's a little paragraph above it. It says if a principal P is invested for 2 years at an annual rate R, compounded in times per year, then the amount A or the beginning balance can be found with this formula. So we're going to do what with this? We're going to write 17 on top?
Yeah.
No, what do we have to do with the percent? You knew what you were doing. Yep. 0.17 for 17%. N represents the number of times it's compounded in a year. How many times is quarterly? 4. 4. So I'm going to write a 4 underneath that. You need to know what the word quarterly means. So there's 4 quarters in a dollar, there's 4 quarters in a year. You're earning interest 4 times every year. For your exponent, you want the number of times it's compounded in a year, which is 4, times the number of years, which is t, and they tell us 2 years. Then comes your calculator. If I type this in my calculator, I would want to go ahead and change this to 8. If you change that to 8, you can type all of this in all at once. So 480 parentheses 1 plus 0.17 divided by 4, close your parenthesis, caret key 8.
661.65.
You got it. You should end up with an ending balance of $669.65. Keep in mind, money is always rounded to the nearest hundredth place. On your test, it will be multiple choice. Really don't want to worry about the decimal. Questions on this one? Again, the formula is given to you. You just have to know when to use it. Question number 7, we're graphing a pair of functions on the same plane. We're going to use a solid line for the first one, a dashed line for the second one. Pull out your reference sheet I gave you Thursday, Wednesday. Everybody have this still? Pull it out. The first graph is on your reference sheet. On your reference sheet, look at the graphs in the bottom left-hand corner. Do you have one that says y equals the absolute value of x? What? I don't think I've got that. That's Wednesday? No. Right there. So the first graph is given to you. You just have to copy it down onto your test. How convenient is that? So we're going to copy that graph down. You have to copy it down on your test. I know it's on your reference sheet. You just have to copy it down. So I would just pick points. Absolute value has all like. I have a question. We're not picking the first one. We're picking the absolute value one, which is the second one, I think. I told her I was going to kick her in the shin if she didn't. She'll get one shin. I'll get one. Hey, tag team. So we're picking the absolute value one, which is the one in the top left, right. She's not even paying attention. Right here, this one. Absolute value matches the absolute value. That's why we're picking that one. So that one has points 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4. Yes. We are literally, whatever you just said, I was going to. Yes. If we could copy and paste it, that's exactly what we would do. Silly, I know, but whatever. It's just going to look like a V. It's really just 1, 1, 2, 2, 3, 3, 4, 4. And then you do the same thing on the opposite side. Negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4. And you go all the way up to negative 10, 10, positive 10. Everybody okay with the first half of this problem? I want you to think back when we did transformations. We talked about numbers out at the end, numbers on the inside, right? Remember that? It's been a couple couple days. Anytime we had a number on the inside, it moved us left or right. Always opposite of the sign. So what's this minus 2 going to do? Move us left or right? To the right, how many? 2. So when I make a XY table for this, I know that the original graph's going to be moved right 2. So I'm not going to start at 0. I'm going to start at 2. So, oh, I just wrote -2. Oops. And then I'm going to pick some numbers that's kind of central around 2. I'm going to do, let's see, 3, 4, and then I'm going to go the other side. Oops, 1 and 0. It's important that we pick 2 because that's going to be this bottom point. So that bottom point's actually going to be moved over to, I don't know, it's not actually going to be moved up or down. This negative out in front is going to flip it upside down, and the 0.5 is going to shrink it together just a little bit. So that's why we're going to make an XY chart instead of making you compute all this on your own. We're just going to use our calculator. So, well, we're kind of going to use our calculator. So -0.5, absolute value, and then we're just plugging in these 5 numbers. So 2 minus 2. If I take 2 minus 2, what do you get? 0. What's the absolute value of 0? 0. What's 0 times -0.5? 0. 0 times anything is just 0. So our first order pair that we can graph is the order pair 2, 0. So it's 2. Then I'm just going to pick another one. If I pick another one off my list, it's still -0.5 times the absolute value. In this case, 3 minus 2. So you've got to do the absolute value before you can use your calculator. Multiply 3 minus 2 is 1. What's the absolute value of 1? 1. What's 1 times -0.5? -0.5. So that gives us the order pair 3 comma -0.5. Well, 0.5 is 1/2, so I can go to 3, 1/2. Then I'm going to go to 4. This time I'm going to take 4 minus 2. 4 minus 2 is 2. The absolute value of 2 is 2. 2 times -1/2 is -1. Then we're going to plug in 1. Here I'm going to take 1 minus 2, which is -1. Absolute value of -1 is 1. 1 times -0.5 is -0.5. So that gives us the order pair of 1. Comma -0.5. Remember, these should be exactly the same on both sides. It is symmetrical. So then if I plug in 0, zero minus 2 is -2. Absolute value of -2 is 2 times -0.5 is -1. Yes, anytime you take the absolute value, it's measuring the distance from 0. It's always going to be positive. So in this case, we're just subtracting all of these and then take the positive of whatever we get. But make sure you add or subtract them first. Same way on your test. You may or may not on your test be able, so it's multiple choice, right? If you can identify this, figure out which one has this point moved to the right 2, left 5, left 12, whatever it happens to be, you can get your answer. You won't even actually have to do this. So if you can identify the shift here, you can figure out what graph you have. And again, if that's negative, it's going to flip it upside down. So we actually could go ahead and dot these if I continued. Maybe if I can draw. Ish. It's kind of ugly, but it's there. So you would just use your ruler. If you wanted to pick some more points that are out here to get a better graph, you could. But as I said earlier, if you can tell me which one's been moved to the right 2 of all your multiple choice guesses, keep in mind it's going to be flipped as well. You'll be able to tell your answer. You keep forgetting they're multiple choice. Questions, other questions on this one? So I'll make sure for this one you can tell me what shift is going on here. So this bottom point is going to be shifted, in this case right 2. Boom, right 2, that's the only answer I have. And you'll be done with your test. And it's worth 5 points.
So we don't even, so we're about to equation, we don't even gotta do the little small stuff.
Right. Because it's multiple choice. I forgot it was multiple choice when we started doing it. Because the one on your test is multiple choice. So you'll be able to just say, hey, which one of these has that bottom point move right 2? The negative is what makes it upside down. Boom, you're done. May or may not be negative on your test as well. This negative out front is what makes it flip upside down. The 0.5 is what makes it stretch out a little bit. Just that negative is what flips it over.
That means you go down, huh?
What's that?
That means you go down, huh?
If I would put a negative out here, like if I would put -6, then it would move down 6. It's not going to happen on your test.
How would you say?
So it works out nicely because it's multiple choice. It could really take you 30 seconds and you'd be done with it. Question number 8, find the domain and range of this log function. F of x equals log base 8 of 3 minus x. We're going to write our answer in interval notation. We've done this. Oh, right. I will tell you, for your test, the answer for the range is always going to be -infinity to +infinity. Guaranteed. Anytime you have a log function, your range is going to be -infinity to +infinity. Anybody remember how we have to do a little bit of math to find the range? I mean the domain. Has to do with this. So remember, whatever's in your parentheses is not allowed to be negative. So we have to take what we were given, 3 minus x, has to be greater than 0. It can't be negative, so it must be greater than 0. And then we just need to solve for x. A couple different things we can do to solve for x. What do you want to do? Subtract 3, okay. That's one of the ways. So if we subtract 3, it's very important that we bring this negative down that's in front of the x. Excuse me. So now we have negative x is greater than negative 3. How do I get rid of that negative that's in front of the x? Divide by negative 1. What happens when we divide by a negative? What happens to this? It flips signs. This is going to turn into a positive. You have negative 3 divided by negative 1. So now you have x is less than 3. So my arrow is pointing to the left, right? If I make this right here an arrow, points to the left. That means my x values are getting smaller and smaller and smaller, and they stop as soon as I get up to 3, which means negative infinity, comma, 3. So any number that's smaller than 3 works all the way up until you get to positive 3. So since this arrow is pointing to the left, that's how I know it continues to the left forever. That's where the negative infinity comes. 3 is where it stops because my numbers cannot get any larger than 3. Yep, your range is always negative infinity to positive infinity. Guaranteed. So when you get to your test, you may or may not be able to mark out an answer because the range isn't correct. So it is multiple choice. Don't let them all being very similar confuse you. Like I would go ahead and write my answer out to the side before I looked at them. Because other than one of them, it doesn't have the correct range. They all have different variations of the same answer. With negatives, without negatives, flipped. Like they've tried to make it tricky for you. Because this is pointing to the left, it's going towards negative infinity, all the way up until it gets to 3.
So if it goes to the right, then
It's
so the first thing to always be negative infinity for the domain 2.
if your arrow is pointing to the left. So since my x is less than 3, any number that's less than 3 works. So I can have negative 100,273,653 would work because it's less than 3. Before wouldn't work because it's greater than 3.
So if it's greater than 3, then what?
You would write the 3 over here and then infinity over here, positive infinity over here. Because it would be greater than any number that's greater than would work. So you just flip them and make the infinity positive, if that happened. Okay. Question number 9. So question number 9 is a little bit harder than what we actually did in class, but I have faith in you. And I'm going to make it harder for next term students, just so you can see this before today. So we're going to rewrite this using sums and or differences of multiple logs. We're going to break it apart. You know how to do the breaking apart. So we're going to break this apart into multiple logs, log base 3. In the numerator, I have multiplication. How do I break multiplication apart? Addition or subtraction? Addition. So I'm going to have x squared plus log base 3 of the 4th root of y. And then for the denominator with the 9, it's division, so I'm going to subtract log base 3 of 9.
Wait, why are you going to subtract the log?
So the denominator gets subtracted because it's a fraction. It's being divided by 9. This looks like a subtraction sign, so you subtract the denominator. Are we okay so far? So technically you could have done it in 2 separate steps, but might as well get it over with in 1. And then remember, anytime we have a number out as an exponent, it gets brought down out front. So this first log is actually going to be 2 log base 3 of x. Are we okay with that one? The next one's where it gets tricky. I want you to look just at the fourth root of y. Remember back when we would convert this to y to the something power? Remember when we did that? It's been a while ago. Remember our exponent went to the top of our fraction, the index went to the bottom. So this has an exponent of 1. So the 1 goes up top, the 4 goes to the bottom. We can rewrite this as y to the 1/4 power. Which means, what would we have to do with that 1/4 if it's an exponent now? What do we do with the exponent over here? We brought it to the front. So here we would bring the 1/4 to the front. So 1/4 log base 3, the y stays there. It's going to be really important on your test that you pay attention to what number's here and what number's down there.
How much is this? It's worth 6 points on the thing.
It's multiple choice.
I'm skipping.
No, you're not. Make sure that if I'm taking the fourth root in this step, that I have the 1/4 power out here. On your test, they might go from 1/4 to 1/3 and try to confuse you. Anytime that happens, mark it off. Process of elimination, you can get the correct answer on this one. Are we okay with that one? So we had to rewrite it like this. Again, make sure if it's 4 here, it's got to be a 4 there, which means the 4 has to be in front. If it's a cube root here and they have a 2 there, something's wrong. They're wrong. It's not the right answer. There might be a couple you can mark off if you're just paying attention. Because you're not going to leave it blank. Yeah. It's fine. All right, the last one, subtraction, right? Keep in mind, it has to stay subtraction. If it doesn't, it's automatically wrong. There may or may not be an answer that has a plus sign for subtraction. We can mark off a number. And then log base 3 of 9, we had to solve this. Now, 9's not an exponent, so only exponents get moved out front. I want you to type this in your calculator using the change of base formula. Change of base formula says take log 9 divided by log 3. Something crazy is going to happen. It's not really crazy. So do change of base on just this portion right here and tell me what you get. Did you just say 6? 2. So that actually equals a whole number, and they go ahead and simplify it to 2 or whatever it happens to be on your test. And that's your final answer.
Yeah, how'd you get to?
We took log 9 divided by log 3. Change base form. So we couldn't do change base on this one because it has an x in it. Can't do change base on this one because it has a y in it. This one just has 2 numbers. So change base top number divided by base log 9. Log 9 divided by log 3 is 2. You just type it in your calculator. Oops, I can't type 2 in the box. So log's right underneath the second button. So log 9, close your parentheses, divided by log 3. You get it? Are we okay? Really only took us 2 steps, but we had to do these 2 little odd drops over here. Keep in mind, multiplication is addition, division, this division bar looks like subtraction, so that last thing in the denominator had to get subtracted. Those are on your reference sheet if you need them. All right, question number 10. The company's weekly cost in dollars is given by this equation where X is the number of items produced during the week. For what number of items is the cost minimized. Remember, we have this parabola. You don't have to draw this. What?
Well, I just like, I took those numbers and reduced it by 5.
Okay. Well, then what?
I did the asterisks.
You're working way too hard. So I want to find out this bottom number. I'm trying to minimize cost. I have to figure out how many items they have to produce to get this cost, this bottom cost. I just need to calculate negative b divided by 2a. Remember, that's the x-coordinate of your vertex, negative b divided by 2a. It's in the bottom right-hand corner of page 1 on your reference sheet. So negative b divided by 2a, we're just going to label a, b, and c. A, oops, b, c. I'm just using these 3 numbers to plug in to that formula. So negative b means the opposite of negative 200, which is positive 200, divided by 2 times a, which is 5. So really, I'm going to take 200 divided by 10.
So I can do that with the reduced numbers, I guess.
I don't think it'll work, because you can't, if you're reducing, you have to be able to reduce over here. I mean, you can factor it out. It might work.
That's the one that.
What can I find?
It might work. Give me a second. Let me look.
I don't know.
I put 5
So,
in,
oh man.
I put 5 in the parentheses, I put x squared minus 40x plus 200. Those are some big numbers.
We don't have to use C. All we have to use is A and B.
So it's not gonna work. Yeah, I did it.
Not to get the right answer. So we're going to take 200 divided by 10 to get 20 items. So one you may or may not have on your test will have a bunch of decimals in it. Use them just the same. Negative b divided by 2a. Find that number for x.
So we'll do it, it's not big numbers, like,
So this is a quadratic. It's going to look like this. We're trying to find that minimum value. So the x is going to give you the number of items. If I would ask you to find the cost, the minimum cost, you can plug it back in to find the cost. But we don't have to do that. This is it. I want to say the one on your test, you're going to find the number of years after, say, 1990. So if I find 8 years after 1990, it's going to be what year? 1998, right? So just be aware of that. I'm pretty sure that happens on your test. Question number 11. We just did this last week. Should be a professional. No, I'm just kidding. So this is just a calculator problem. What 5 numbers do we always use when we're finding exponential growth or decay?
-2.
Yep, -2, -1, 0, 1, and 2. So all we're gonna do is plug in these 5 numbers into this equation. Again, calculator work. So first one, I'm gonna type 3 caret key -2 plus 2. Ooh, I wonder if you have to use parentheses. Oops. Nope, don't even have to use parentheses. So 3 caret key negative 2 plus 2 in your calculator. So caret key came from this being an exponent, and negative 2 came from that's the x value we were plugging in.
This is great.
What?
Well, it's because you use the minus sign. That can make it negative. So use this one as a down. Just like it. See how little it was? We changed it to really tiny.
You should get 2.1 repeating. So 2.111111. Then all you have to do is go type over, scroll over, change that negative 2 to a negative 1 to get your second answer. So 3 caret key negative 1 plus 2.
2.3.
It's not what I meant. Oh, it is 2. And change it to a 0. Oops. So keep changing them until you get all 5 numbers.
For the 1 and 2, do you change it to positive?
Yep, it's gonna be a positive one. It's just
But these booklet lines mean not equal.
It means I've rounded it. It's an approximation.
Or a negative error, whatever that.
We deleted the negative?
Oh, because you don't do positive.
So you just use 1. Because that plus sign tries to compute it as something plus 1. Not yet. What's what mean?
The T at the.
Oh, it's a 1 repeating this. 1 repeating.
You said this is.
Recording it.
What?
I said I'm recording it.
So I'll be later.
So with these 5 values, we're going to go ahead and graph them. So if I graph negative 2, comma 2.1, maybe right there. 2.3 is just a tad bit above. 0. Oh, that's not even the right spot. Hold on. Here. There we go. 0, 3, 1, 5, 2, 11. Well, 2, 11 doesn't really fit on your graph, but you can approximate it. So it looks to me like the left side's getting closer and closer and closer to 2. It's not going to cross 2. It's going to get closer. So we had 2.3, 2.1. It's just going to keep getting closer to 2. So make that like level out on the left side. And as I said earlier, this will be multiple choice. You just have to pick the graph.
So when we do that, we gotta make sure it's on the negative on the 2.
It's just going to keep getting closer to 2. Because it's been moved up from the original. And then we knew this was exponential growth because we had 3 here. So any graph that's not exponential growth, you know, was going to be wrong. The plus 2 out at the end told me it was going to move up 2. So I had growth and it was going to be the original parent function, moved up 2. So I had a general idea what it should have looked like before I even started. Other questions on this one? Question 12 is an Algebra 1 problem. So in January of 1983, Anna started a new job and makes an annual salary of $38,000. By January of 1986, her annual salary has increased to $46,300. What is the average rate of change in her salaries between 1983 and 1986? Anybody know how to do this? So we need to figure out how much more money is she earning. So we're going to take 46,300 minus the original salary that she was earning, 38,000, divided by the number of years that have passed. So 1986 minus 1983, you might not even have to write that down. So her salary has increased $8,300. And from 1983 to 1986, 3 years have passed, right? So in 3 years, her salary has increased $8,300. So we're going to take the amount of money that her salary has increased, and we're going to divide it by the number of years to figure out the average change in her salary every single year. You got it. 6, 7. So figure out how much more money she's earning and divide it by the number of years that have passed. One of your tests might be about feet and minutes. How far something's traveled in a certain number of minutes. Take the feet, subtract them. Take the time, subtract them, divide. It's technically the formula for slope, which is in the top right-hand corner on your reference sheet. y2 minus y1 divided by x2 minus x1, if you remember from Josh's class, or Algebra 1, wherever you had it. Oh, I should label it dollars. And like I said earlier, it is a multiple choice question on your test. Questions on it? Question number 13. We're given f of x and g of x, and we're asked to find f minus g and then plug in 2. So we're going to take f minus g, so take the entire function f, copy it down. So f is 3 minus 2x. And then we're going to subtract g of x, which is negative 9x squared plus 4. We're going to finish this one and then take our break. So tricky thing here, since this is subtraction, you're going to distribute that negative into your parentheses, which changes all your signs. Biggest mistake I foresee happening is that right there. So with subtraction, you've got to distribute the signs. So now we have 3 minus 2x plus 9x squared minus 4. All you can really do with this is combine like terms here and write it in standard form. 9x squared minus 2x minus 1. So that's f minus g. And then what do we do with this 2? We'll plug it in. We've got to plug it in 2 times for x, so it turns into a calculator problem now. So 9 parenthesis 2 squared minus 2 parenthesis 2 minus 1. Calculator. Make sure you're using those parentheses. What do you get for your answer? 31. Okay, so moving on to question 14. Question 14 says find the remainder when this polynomial is divided by x minus 2. So easiest way to find a remainder is to do synthetic division. If you want to do long division, that's fine too. What would you prefer? Synthetic or long division? Synthetic, how did I know? So remember with synthetic division, we need 3 rows every single time. The number of columns depends on the number of terms that we have. So it looks to me like we have 5 terms, so we're gonna need 5 boxes. Oops. Can't say it's not very evenly. So our coefficients go in the box across the top. So coefficients are just the numbers in front of the variables. So here we have 2, -1, -7, -3, and +10. Those 5 numbers are what's going to go across the top. So 2, -1, -7, -3, and 10. The tricky part you need to remember, how do I get the number that goes out here on the ledge? So I'm going to take this and I'm going to set it equal to 0 to solve for x. Well, x minus 2 equals 0. Add 2 to both sides to get that x equals 2. So whatever x equals is what goes up on the ledge right here. Remember, the first number always gets brought down. So here the 2's getting brought down right there. And then we start our cycle to fill in the rest of the boxes. How do we start our cycle? What do we have to do to get the middle number? Yep, we'll multiply to get the middle. 2 times 2 gives me 4. How do I get the number at the bottom? -1 plus 4. -1 plus 4 is 3. How do I get back to the middle? Multiply to get the middle. 2 times 3, which gives me +6. We're just multiplying and adding, multiplying and adding. So we multiply now, we want to add -7 plus 6 is -1. -1 times 2 is -2. Then I'm going to add -3 plus 2, which is -5. And then -5 times 2 is -10. +10 and -10 combine to give me 0. Keep in mind, what was the question asking us to find? The remainder. Which one of these 5 numbers is our remainder? 0. This last box is always, always, always your remainder. This will be multiple choice on your test, and the remainder will not be 0 probably, since it was here. So do your synthetic division, whatever you get in that last box is going to be your remainder. Say that again. But the remainder is 0. So on your test, it's going to be multiple choice. You're going to circle A, B, C, or D that has the same answer as your remainder.
We gotta draw the box with the box ID.
You have to draw the box. Again, I didn't write the test. I'm not allowed to modify it. Are we okay with this one? Okay. Ooh, this question, this lesson got cut out because we only have 28 days instead of 32. It happens every few terms. So this question deals with in behavior. It is kind of fill in the blank / multiple choice, so I don't really feel like terrible that we didn't get to it because you could kind of go off. So for this one, the leading coefficient is either positive or negative. All you have to do is look at the in behavior here. So if I look all the way on the right of my graph, is this going up or is it going down? Up. It's going up, so it is positive. Circle over top. Maybe, maybe not. If this would happen to not turn and would just keep going down, it would be negative. So it's all based off where this is going at the right side. So if it's going up, it's positive. If this would happen to continue down to the right, it would be negative. The degree, I'm looking at both in behaviors. This one's going down, this one's going up. They're going opposite directions, so it's odd. So if your arrows, one goes down, one goes up, it's odd. One's going positive, one's going negative, it's odd. If they would both go up, it's even. If they both go down, it's even. All based off where your ends are going. And then for this little box, I don't really know why they do it in this little box, but that's how I detected it, so that's how I put it on your graph. So for this box right here on the left, as x approaches negative infinity, that's telling you to look at the left side. If I look at the left side, where's this arrow going? Down. So am I going to put negative infinity or positive infinity? Negative. So I'm going to write y approaches, y, arrow, negative infinity in that first box. And I promise they'll be in the same exact order on your test. So for the left one, you're looking at the left. For the right one, you're looking at the right. Tell me whether your y values are going towards negative infinity or positive infinity.
Okay, so the right of that means that's always going to be the leading coefficient.
Yes.
Okay. So that's always going to be the degree.
No, the degree looks at them both. Both sides is the degree. So degree means, are they going even? Are they both going both up or both down? That's even. Odd means one goes up, one goes down. And then for the last one, you just look at the endpoints individually. This one talks about the left side, so the left side goes down, so it's negative infinity. Here we're wanting to know as x approaches positive infinity, that's the right side. So look at the right side, it's going up. So am I going to write negative infinity or positive infinity? Positive infinity.
We just tell me it goes down, but change the x to what?
Yeah, well, you're either filling in with this top thing here or this top thing here. They give them to you on your test. So this talks about the left arrow and the right arrow. If it goes down, you write negative. If it goes up, you write positive. So there's a chance on your test that you might write the same thing here. If it's even, you'll write the same thing down here twice. Because they both go up or they both go down. So leading coefficient, if it's positive, it'll go up to the right. If it's negative, it'll go down to the right. The degree means, do your arrows go the same direction? If they're even, they both go the same direction, either up or down. If it's odd, you have one going up, one going down, doesn't matter which one's where. For part C, you're talking about in behavior. The first box is going to talk about the left side. The left side goes down, so that's why we chose the negative infinity. For the right side, the arrow went up, so we chose positive infinity. Again, it's a short term, so this got cut out. But hopefully it's not terrible. And it's a 50-50 shot on all of them. All right, moving to question 16, which we have done this term. Find the inverse of this function. Remember, to find an inverse, you're going to take f of x out, replace it with y for step 1. Once we do that, what do we do next? Switch the x and the y. So we're going to change this to x equals, in parentheses, y minus 3 squared plus 2. So first step, take f of x out, replace it with y. Step 2, change or switch, invert the x and the y. Now our objective is to solve for y. What should we do first? Subtract 2, perfect. So we have x minus 2 on the left side equals y minus 3 in parentheses squared on the right.
So we're gonna take the radical.
So we're going to take the radical, we're going to take the square root in this case, since this is an exponent of 2. If you want to write the 2 in there, that's fine. So the square root, or the second root, cancels out the exponent of a 2. So this is going to cancel with this, and it just leaves you with your parentheses, y minus 3. For the left side, do we know what the square root of x minus 2 is? No. You're just going to write the square root of x minus 2. Don't do anything with it. Leave that square root on it. Still trying to get y by itself. What do I need to do? Add 3 to both sides. Can I add the 3 to this too?
No.
No, it's being protected by that square root. So I'm going to write the square root of x minus 2, and then hanging out behind it, I'm going to put the plus 3. Then we're going to rewrite it back in inverse notation. So f inverse of x, if it would write for me. And that right there is your final answer. Keep in mind, this is question 16, so we've moved to the free response. It's not multiple choice anymore. Which is kind of nice because now I can give you partial credit for things. Which is what I like. Questions on this one? So we've done this, it's just been a couple weeks. Am I going too fast? Nobody's gonna talk? Okay, perfect. Question 17, we're going to simplify this expression. We've done this before. We have to multiply by the conjugate. How do we get the conjugate? Has to do with flipping something in the denominator. What are we flipping? The sign in the middle. So we're going to copy the denominator down, but we're going to change it to 3 plus 2i. If I multiply the denominator by 3 plus 2i, I have to multiply the top by 3 plus 2i. And we've just created ourselves 2 box problems. So we're going to box the numerator, and we're going to box the denominator. All right, so I'm going to box the numerator up top. So the numerator is I plus 5, and we're multiplying it by 3 plus 2i. And we're just going to fill out our boxes. So the top left box, I'm going to multiply 3 times I. 3 times I is 3i. Top right box, I'm going to take 3 times 5. 3 times 5 is 15. The bottom left box, I'm going to multiply I times 2i. Be careful. I times 2i is 2i squared. What does I squared change into? Negative. So -1 times 2 is going to give you a value of -2 for this box. Notice the way they have it written has moved that to the bottom left box instead of the bottom right box where we're used to it. And then the bottom right hand box, 2i times 5. 2 times 5 is 10. There's just one I, so bring it down. So for, the numerator, I'm going to combine like terms. Here I have like terms, -2 plus 15 is 13. And then when I combine my i's, here I have 3i plus 10i which gives me 13i. My box disappeared. I have to erase it. Don't mind me while I figure this out. All right. So then for the denominator, we're going to take the original denominator, multiply it by the conjugate. So 3 minus 2i, the original, and the conjugate 3 plus 2i. Doesn't matter where you write which one, as long as you have both of them. So this is the denominator. When I multiply corresponding parts, 3 times 3 is 9. When I multiply 3 times negative 2i, I get negative 6i. When I multiply 3 times 2i, I get positive 6i. That bottom right box, we have negative 2i times positive 2i, which happens to give you negative 4i squared. Keep in mind, you're never allowed to give me anything with I squared in it, so you're going to take I squared out, replace it with negative 1. Negative 1 times negative 4 is positive 4. When I go to combine like terms here, I have 9 plus 4, which is 13. When I go to combine my i's on this diagonal, I have negative 6i and positive 6i. When I add those together, they cancel each other out. What do you notice about this fraction that we have left? They're all 13s, right? So I can reduce them all. So keep in mind, since this is a fraction, our instructions for some reason want us to write it as a plus bi. That just means they want us to simplify into 2 pieces. So on your test, you would write, if it didn't simplify, which I don't think it does on your test, 13 over 13 plus 13i over 13, which in this case, then you would have to reduce them to 1 plus I or 1 plus 1i, depending on how you want to write it. But on your test, you're probably going to keep it like this. You'll have numbers that don't reduce. So if I just change the denominators to 12s or whatever it had to be. Questions on that page? Okay. Question number 18, we're going to solve this absolute value equation. We did this a long time ago. So this is back week 1, we did absolute value equations. First thing you want to do with absolute value equations is get your absolute value bars by themselves. It's very important that you follow the order of operations kind of to get them by themselves. The first thing you want to do is get rid of anything out here. So we want to get rid of the plus 10 by subtracting 10. If we subtract 10 on the left side, we have to subtract 10 on the right side of your equal sign. So that's going to give me 2 minus my absolute value bars and everything inside of them equals negative 10. I want you to be very careful on this next step. So that minus sign does not belong with the 2. That's a positive 2 minus, think of it as a negative 1 times your absolute value bars. So we want to subtract that 2, but that's going to leave that negative sitting there. So we're subtracting 2, we still have that little negative 1 that's being sneaky right there. And now we have negative 12 on the right side. It's very easy to get that So my suggestion would be that if that happens on your test, that you write a little 1 in there, like I just did in blue.
Yeah, that's what I did. But I divided it and then I added the one.
Mm-mm. So the -1 in this case is being multiplied by your absolute value bars. So for our next step, since that -1 is the only thing left over there, I want to divide by -1 to cancel it out. Once you get your absolute value bars by themselves, there's no negative signs in front of it. There's no numbers hanging out after it before the equal sign. This is where you make the split into 2 problems. We're going to solve one of these as x plus 3 equals 12. So x plus 3 equals 12, and then x plus 3 equals -12. So those are the 2 problems we're going to solve. They're really not that terrible once you get to this point. So x plus 3 equals 12, subtract 3 from both sides, and x equals 9. There's one answer. Circle it, box it in, do what you do. For the second one, you're again going to subtract 3, but this time you have -12 minus 3, which is -15. So 2 answers. You'll always have 2 answers for any absolute value equation that you're solving. Questions on this one? No, you're good. So for question 19, we're going to solve this equation. Now remember, they've thrown back to check your solutions in the original. That means something funky might happen. You might end up with an extraneous answer. So to solve this one, you need to isolate the radicals, subtract 4 from both sides. That gives you the square root of 11 minus 2x equals x minus 4. Now that we have the square root by itself, we can go ahead and get rid of it by the inverse of a square root. Opposite of a square root is squaring. So we're going to square both sides. When you square the right side, it turns into a box problem. So we squared the left side to get rid of the square root to get 11 minus 2x. But the right side, when we square it, turns into, again, a box problem. We need to take x minus 4 times x minus 4. So in my box, I'm going to take x times x, which is x squared, -4 times x, which is -4x, -4 times x, which is again -4x, and then your last box, -4 times -4 is +16. So when I take x minus 4 and I square it, that means I have to make a box problem with x minus 4 on the top and x minus 4 on the side. So then when I combine like terms, I'm going to end up with x squared minus 8x plus 16 for the right side. Ask yourself, is this quadratic or linear? So linear just means it has plain old x's in it. Quadratic means it has x squareds in it. Quadratic, anytime you have quadratic, you want to get 0 on one side so that you can factor it using your asterisks. So we're gonna move the 11 by subtracting 11. We're gonna move the 2x by adding 2x. So we're gonna subtract 11 and add 2x to both sides. Nothing combines with the x squared, so it comes down. Then I'm gonna take negative 8x plus 2x to get negative 6x. I'm gonna take 16 minus 11 to get positive 5. And again, I have a quadratic, so I want to see if I can factor it using my asterisks. It does look like a problem that will factor that way. So 1 in the top left, top right, negative 6 in the bottom middle, and positive 5 in the top middle. So we're looking for two numbers that multiply to give us positive 5, but add to give us negative 6. Negative 5 and negative 1. Perfect. Those multiply to give me multiply to give me 5 and add to give me negative 6. So now my factors, if I look at the two fractions here, neither one reduces. So the first one's going to turn into x minus 5. The second one's going to turn into x minus 1. Then I'm going to set them both equal to 0. To get my two solutions. But remember, we're not done yet. We have to go back and check these in the original because, again, since they told you to check in the original, there might be one that doesn't work, especially because they took the time to put it in your instructions. So if I go back to check 5, if I go back to check 5, that means I'm going all the way back to the original. 11 minus 2 times 5 underneath the square root plus 4 equals x. Well, x was 5. So then I would just start simplifying. Underneath my square root, I have 2 times 5, which is 10. So really this is 11 minus 10. Well, 11 minus 10 is 1. So now I have the square root of 1 plus 4. What is the square root of 1? 1. So really this is just 1 plus 4 equals 5. Is 1 plus 4 equal to 5? Yeah, so that answer works. We're going to do the same exact thing to check 1. So we're going to go back to the original. 11 minus 2 times 1. Let's see, square root. Plus 4. So underneath my square root, I have 11 minus 2 times 1. Then plus 4 equals x. Well, x was 1, so equals 1. If I start to simplify, 2 times 1 is 2, 11 minus 2 is 9, so the square root of 9 plus, 4. The square root of 9 is 3. Is 3 plus 4 equal to 1? No, definitely not. That one does not work. This is extraneous. Make sure that you don't circle it as part of your answer. You can mark it out. You can write extraneous. Just make sure you check them both. Circle 1 or 2. If you have one answer, just circle 1. If both of them work, circle both of them. I promise at least one will work. Questions on this one? Question 20, we did this last week. So remember, for asymptotes, for vertical, you're going to the denominator and you need to factor it. So go to the denominator, factor the denominator, this right here. It's just an, yep, just an asterisk problem. So 1, 1, 6, and negative 27. Let's see, two numbers that multiply. Two numbers that multiply to give me negative 27 and add to give me 6. Negative 3 and positive 9. You got it. So 3 times 9 is 27. We want the 3 to be negative so that we can add to get positive 6. So now I have factors x minus 3 and x plus 9. Go ahead and set them both equal to 0 to get your vertical asymptotes at x equals 3 and x equals negative 9. Yeah, you're just, if you would set them x minus 3 equal to 0, you would just add 3 to both sides, which gives you x equals 3. X plus 9, excuse me, equals 3. Subtract 9 from both sides, get that negative 9. So that's one part of your answer right here. The next thing we're asked to find is horizontal. Remember that anytime your exponents are equal, they're x squared and x squared, one on top, one on bottom, you set your coefficients as a fraction. So coefficient on the top is this 3. What's the coefficient down here? What number is sitting in front of x squared? 1. So your horizontal, I'm going to label HA, is just going to be y equals 3. Set your coefficients into a fraction, in this case 3 over 1, which reduces to 3. I promise it'll be that simple on your test. Circle it, box it, and there will be no oblique asymptotes because you have horizontal and vertical. Are we okay on this one? Okay. So it's right there. So you're gonna hit second, this button, and then just type. No, you're good. For question 21, we're going to solve this inequality. We're going to write our answer in interval notation. I think this is the other lesson that got cut out, if I remember right. First thing you want to do is factor it. So take x squared minus 10x plus 24. Whoops, not box. Factor it. So for this, I would have 1, 1, negative 10, and 24. Looking for two numbers that multiply to give us 24, add to give us negative 10. Negative 6 and negative 4, perfect. So those multiply to give us 24, add to give us negative 10. So now we have factors x minus 4, x minus 6. Oh, I guess. Then we're going to set them both equal to 0. You get x equals 4, x equals 6. This is where things get tricky. So everybody okay with factoring, setting them equal to 0? You should be professionals at that by now. So to figure out our answer, we have to draw ourselves a number line. Guess what two numbers matter on our number line? 4 and 6. You're so smart. So here's 4, here's 6. I don't really care what other numbers you put on your number line. I would just write 4 and 6. And then we're going to have to check regions. Would you agree that on this number line, there's a region here, a region in the middle, and a region on the right? There's 3 regions. We need to pick a number from each region and check it. So give me a number that would be in this region. So any number smaller than 4? Why would you not pick 0? So I would pick 0. Easiest number I can think of is less than 4. So I would check 0. So let's check 0. So if we check 0, that's checking this region over here on the left. If I plug 0 back in, I would have 0 squared minus 10 times 0, I guess, plus 24 is greater than or equal to 0. I went all the way back to the original. I took out both the x's and replaced them with 0. Type that whole left side into your calculator if you want, or tell me what it equals if you know. I think that's what you just said. You should get 24. Ask yourself, is 24 greater than or equal to 0?
Yeah.
If you have $24, do you have more than 0 or less than 0? More than 0. So this region over here at the left works. It's part of our answer. I'm just going to put a little check mark there. It works. So that region has to be a part of my answer. Then I'm going to check a number that's between 4 and 6. What number do you think I'm going to check that's between 4 and 6? Yep. So then we're going to check 5. Again, go back to the original. 5 squared minus 10 times 5 plus 24 greater than or equal to 0. Tell me what you get for the left side. Okay, let's say a -1. Did you get -1? Is -1 greater than 0? No. So that 5 came from this middle region. The middle region is not part of my answer. One last one to check before we're done. Give me a number that's greater than 6. Any number doesn't really matter in this case. What did you say, 8? Did you say 8? Sure. So we were told to check 8. Again, it doesn't matter. Any number that's greater than 6, make sure you can't plug in 6. You can plug in 7, 8, 9, 10, 12, 200, however big you want. So then we're going to take 8 squared minus 10 times 8 plus 24 and see if we get a number that's greater than or equal to 0. I got 8. Oh, no, it's fine. You can do 7. If you add 3, 3 is still greater than 0, right?
Yeah.
So we're getting for this one that 8 is greater than or equal to 0. Is 8 greater than or equal to 0? Yes, so this region is going to work. So we have 2 regions that are part of our answer. The tricky part is writing the final answer. So we have to write an interval notation. Would you agree that this arrow continues to the left forever and ever and ever and ever and ever? And it's part of our region. So for this region right here, we're going to have negative infinity because it goes to the left forever and ever, all the way up until it reaches 4.
Where did we, oh, here, let's move down.
Since this can be equal to, our endpoint is included. So that's when we use that fancy bracket. So we can use this fancy bracket because it has the equal to in the original. So that's the left part of our answer. Then we're going to create what's called a union. You're just going to write an uppercase U like this. It's called a union. We're uniting our two answers. It's a fancy way of saying this and this. So then for the right side, would you agree we start at 6? So I'm going to write 6. And this arrow goes all the way to what? Positive infinity. We'll never ever reach there, but we're going to get as close as we can. So this right here is actually your final answer. If you can get pretty stinking close to that, you're doing great. Again, I don't expect anybody to get 100 on this final. I can pull up your grade and tell you what you can get and still pass. Questions on this one? Ooh, 22. What's up? You done? Oh. Good. You done? Perfect, thank you. All right, question 22. Find all the real and imaginary zeros. Remember, this is where we did our P's and our Q's. All the factors of 2 divided by all the factors of 2. Remember doing this? Those are P's and our Q's. So all the factors of 2, plus or minus 1, plus or minus 2. Plus or minus 1, plus or minus 2, since they happen to both be 2's. The factors of the constant and leading coefficient. It's just the technical definition of it. Anybody remember? So we have plus or minus 1, plus or minus 2, plus or minus 1 half. 1 over 1 is 1. So we have these 6 numbers that we can try using synthetic division. What number would you like to start out with? 1. Michaela's saying 1. So we're going to try synthetic division with 1. Remember, if 1 works and we get a remainder of 0, we're going to move on. So synthetic division again. My lines are crooked. That's fine. In your box, you write your leading coefficients, 2, 1, negative, 5, and 2. I'll pause for a moment because I know I'm going fast. Are we okay so far? Okay. So to fill out our synthetic division, bring that first coefficient down. So the 2 comes down. Then we're going to multiply to get the middle. 1 times 2 is 2. Then we're going to add. 1 plus 2 is 3. Multiply to get the middle. 1 times 3 is 3. Add to get the bottom. Negative 5 plus 3 is negative 2. Multiply to get the middle. Negative 2 times 1 is negative 2. And what's our remainder? Oh, 0. It's glorious when that happens. So 1 was the magic number here, which means I would go ahead and write my solutions, and I'm going to put x equals 1 in my solutions list automatically because it worked right here. So we factored out a 1, so 1 must be a solution. Then we're going to take the quadratic that's left. Remember, down here are all the coefficients to your quadratic. The remainder is 0, so we're going to ignore it. So we have 2x squared plus 3x minus 2. And we're going to see if we can factor that. So we're going to put it into our asterisks. 2, 2, 3, and be careful, negative 4. Because you're going to multiply a times c. First times last.
Oh, yeah.
You're right. So make sure for that top middle, you're going to multiply 2 times negative 2. It's always a times c. And then we're looking for 2 numbers that multiply to give us 4, but add to give us 3. 4 negative 1 is perfect. This time I can reduce, so I want to reduce this 2 and 4 to 1 and 2. So now I have x plus 2 as a factor and 2x minus 1 as a factor. What should I do now? You got it. Set them both equal to 0. The first one's pretty easy. X plus 2 equals 0, which means x equals negative 2. I'm going to add that to my solutions list that I lost on my screen. And then for the last one, I have 2x minus 1 equals 0. I'm going to take, add 1 to both sides. So 2x equals 1, divide by 2, and x equals 1/2. Yep, add that to your solution. So you have 3 solutions, 1 negative 2 and positive 1/2. Biggest mistake I saw when we actually did this in class is students getting these 2 solutions and forgetting to write this one. So make sure you have all 3 of them on your test. Question 23, we're solving this log equation. Notice I have 2 logs on the left and no log on the right. So I can't just cancel out logs. The first thing I want to do is combine the 2 logs on the left. How in the world do I combine 2 logs that are separated right here with addition? Somebody said it. Multiplication. So I'm going to have to multiply x plus 3 times x plus 4. What kind of problem do you think that's going to create? Somebody said it. A box problem. Oh, because I goofed. Thanks. I shouldn't have. X minus 3 times x plus 4. Thank you, thank you, thank you. So we could either box those together now or box them together later. What would you prefer? Now? So we're going to go over here to the side and we're going to box them together. So I'm going to box x minus 3 and x plus 4. So to fill out my box, x times x is x squared. X times negative 3 is negative 3x. X times 4 is 4x. And negative 3 times 4 is negative 12. So when I combine like terms, I have x squared, which stays the same. I'm going to add together these 2 terms right here, the negative 3x and the positive 4x to get plain old x. And then the negative 12 or minus 12 gets brought down. If we do asterisk, we'll go back to the step above us. So at this point, we want to get rid of the log. We can't just cancel it out because there's not a log on the right side. So this is where we have to label them and switch to exponential form. So b y x, and we want to write, b to the x power equals y. So take a minute and see if you can rewrite that as b to the x power equals y. So we're converting it to exponential form. So 2 to the third equals that whole set of parentheses, x squared plus x minus 12. The whole set of parentheses gets brought down. So now we have 2 to the third power equals a quadratic. What is 2 to the third power? 8. 2 to the third power means 2 times 2 times 2. So really we have 8 equals x squared plus x minus 12. Now what do you think I'm going to do? Subtract the 8. So 0 equals x squared plus x minus 20. And what do you think we're going to have you do with this? Asterisk. So here we have 1, 1, 1, negative 20. We're looking for two numbers that multiply to give us negative 20, but add to give us 1. Which one needs to be negative? 4. So the 4 needs to be negative because 5 minus 4 gives us that 1 in the bottom. So now we have factors, x plus 5, x minus 4. Set them both equal to 0, so x plus 5 equals 0, x minus 4 equals 0. Nope. We have to check them. So we found our solutions, but now, remember, my instructions tell me to check them, which means I better check them.
No, yours sounds simple for a random number. Or I just be right way too big. No,
Sorry. I can zoom in and zoom out. Like, my screen's much bigger than what it is on the screen. And I know what to plan for because I've already done it.
see? You know how to organize your life all over the place.
So we're going to have to check both of these. Let's check negative 5 since that's the first one we found. Again, it doesn't matter. If we check them, we're going all the way back to the original. So log base 2 of negative 5 minus 3 plus log base 2 of negative 5 plus 4 equals 3. So all the way back to the original to check them. As soon as I start to simplify this, if I simplify this set of parentheses right here, as soon as you get a negative number inside those parentheses when it's simplified, you're done. You can't have a negative in there. I promise it's not defined. So this I can stop. As soon as I got that negative 8 when I simplified, it's not defined. Your calculator would tell you have an error. So that one can't be a solution. We're going to have to check the other one. So we're going to check 4. So when I check 4, I have log base 2 of 4 minus 3 plus log base 2 of 4 plus 4. If I simplify any of these sets of parentheses, will you get a negative number there? No. If you would actually take, let's see, log base 2. What? No, you can't add them together like that. You'd have to do change of base for the first one. So log of 1 divided by log of 2, which is actually 0. Log of 8 divided by log of 2, which is actually 3. Checks out. Promise you're going to get one on your test that gives you a negative, the other one doesn't. And it's going to work. You would have to do in your calculator log 1 divided by log 2 plus log 8 divided by log 2. Well, you're going to miss one because one of them is not going to work. So you've got to at least do that first step to figure out which one doesn't work. Because more than likely on your test, one of them is not going to work.
So if we find out the one that doesn't work,
The other one will work.
do we have to check it?
write down the first step for me and then move on. So here the -5 didn't work, so our only answer that we're gonna go back and circle is the x equals 4, or square box something. Something to tell me that that's your answer. Two more. We're almost done. Oh, we did. Question number 24. We're going to solve the equation and round our answer to the nearest 4 places. So for this one, the first thing we want to do is get this term by itself. We've got to get rid of that 4. The 4 is being multiplied, so if I want to get rid of it, I'm going to divide. Once I get to here, I'm kind of stuck. I've got an x stuck in the exponent. The only way we know how to get it out is to rewrite it in log form. So currently we have b to the x power equals y, and we want to rewrite it as log base b, so log base 5 of y, which is 2, equals x, which is 2x minus 1. We gotta get x by itself. So I would, since I'm kind of lazy, right? Log base 5 of 2, I want to figure out what log base 5 of 2 is. That's just change of base. So in my calculator, I'm going to figure out what log 2 divided by log 5 is so that I can make my life easier. If my thing would connect. So in your calculator, take log 2 divided by log 5. It's going to give you a nasty, ugly decimal, and that's okay. So in my calculator, it's telling me 0.4306. Oh, technically that would round to a 7, whatever. So your decimal approximation equals 2x minus 1. Then I would add the 1 to both sides. Then divide by 2. And that is it. That is your final answer. X equals 0.7153. An ugly answer, but that's okay. Keep in mind, my instructions say round to 4 decimal places. You've got to keep 4 decimal places. Questions on this one? All right, last one, question 25. We're given f of x and g of x, and we're asked to find the composition f of g of x. So this right here, remember compositions means take this whole function and plug it into f. So we're gonna take this whole function right here in parentheses, and we're gonna plug it into f right here. So if you haven't already, do step 1. You're gonna have 3, that whole set of parentheses squared plus 5. Unfortunately, you can't leave your answer like that. What do you think you need to do? Simplify it how? What's your first step? Can't square it. So you don't have an equal sign. You can't really square root anything. You need to get rid of that squared. How are you going to get rid of it? We're not going to do anything with the 3. So looking just at this right here, that set of parentheses is being squared. How can I get rid of that set of parentheses being squared? I'm going to box it. I'm going to multiply it by itself. I'm going to take 2x minus 7 times 2x minus 7. So since it's in parentheses squared, anytime it's in parentheses squared, you take it and you multiply it by times itself. So 2x times 2x is 4x squared. 2 times negative 7 is negative, 14x. Let's see, the bottom left the box, you're going to take negative 7 times 2x, which is again negative 14x. And the bottom right box, negative 7 times negative 7, negative times negative is positive 49. So the 3 still stays there. We haven't done anything with it. Instead of writing what I have highlighted, we're going to write what we got when we multiply them together. So that's where the 4x squared is going to go. I'm going to combine negative 14x and negative 14x to get negative 28x plus 49 because it's positive. Oh, and don't forget the plus 5. So that plus 5 was in the original. We're just bringing it down. The hardest work's done. Now what do you think we need to do? So I'm going to have to distribute the 3. So I'm going to take 3 times 4x squared, 3 times negative 28x, and 3 times 49. So 3 times 4x is 12x squared. 3 times negative 28 is negative 84. The x comes down. And 3 times 49 is 147. Have we done anything with this plus 5? No, bring it down. You're almost done. You got it. We're going to combine like terms right here. We're going to take 147 plus 5. Everything else stays the same. So 12x squared minus 84x plus 152 is going to be your final answer. That was a lot. Anything you want to see again? All of it.